students, today we will study about electrolysis. As we know, electro means electricity and lysis means breakdown, decomposition. So in simple terms, it is the decomposition of chemical compound with the help of electricity or electrical energy. In other forms, you have studied the decomposition by heat, the decomposition by light, that is called photolysis, decomposition with the help of water, that is hydrolysis, and this time we are going to study about electrolysis. What happens actually when electric current, in the form of direct current, is passed through molten state or aqueous solution state of a chemical compound, then it is decomposed, causing chemical change. Hence, this is called electrolysis. So, we can now define that electrolysis is the decomposition of a chemical compound by passing direct electric current, that is, in short we write DC. The battery and other things are the source of DC current. We will not use alternating current or AC. We will discuss the reason in later topic. So direct electric current in the decomposition of chemical compound by passing direct electric current in their molten or aqueous solution state, leading to chemical change, that is, when electrolyte current is passed through molten or aqueous solution of a chemical compound, then it is decomposed. This is called electrolysis. Actually, this takes place in ionic compounds which consist of ions, or which polar covalent compound which produce ions. Now, so the first of all, it is decomposed into ions and then they are discharged at the electrodes. So we can have another definition also, that is the decomposition of a chemical compound into ions by passing direct electric current through their molten or aqueous solution state, leading to the discharge of ions at electrodes, is called electrolysis. Now students, we see that here we use the discharge of ions. What is it? When the chemical compound is decomposed into ions, now these ions migrate to electrodes, that is positive and negative electrodes, and by loss or gain of electron, by losing or gaining electron at the electrodes, they become neutral. This is called discharging of ions. So students, we see here that is, in electrolysis the chemical change takes place with the help of electric current. Now, it can be made easier, it can be made clear with the help of an example. Just to describe the process, later on we will study its different conditions. Suppose we take electrolysis of molten sodium chloride, NaCl. Just first of all, suppose we have a glass vessel, that is, there should be a non-conducting vessel in which the two conducting rods that may be made up of metal or graphite or gas carbon, which are actually called electrodes. Now suppose we also connect a bulb through it, complete the circuit using the key switch and a battery. This is negative electrode, this is positive electrode. Positive electrode is called anode and the negative electrode is called cathode. Then in the vessel, we take chemical compound in molten or aqueous solution state. So this compound is known as electrolyte. Electrolyte, that will be molten NaCl for this question. Now, when the compound is in molten state, then it will be decomposed, dissociated. Now the term we use dissociation. Dissociation of NaCl. Dissociation and ionization, two terms are used, students. Dissociation word is used for ionic compounds, means separation of ions because ions were already present. And ionization word is used for polar covalent compounds, which were initially molecules but they get ionized in aqueous solution. So this time we are using dissociation. Now you see here the reversible symbol is taken, Na plus and Cl minus. So the ion is formed. Now you see here, that is in this part there are Na plus and Cl minus ions. Now this positively charged ion, that is a cation, is attracted towards the cathode, negative electrode, and chloride ion, which is negatively charged, is attracted towards the anode. So when we write discharging of ions, that is electrode reaction, what happens here? Then there is a simple rule of electrolysis. Rule, that is A to A and C to C, means anion to anode, anion to anode and cation to cathode. Cation to cathode means, you see, that is anion, positive negatively charged ion, migrate towards anode, which is positive electrode, unlike charge attract each other, and cation migrate to cathode, which is negatively charged electrode. Now accordingly, at anode, what will be the reaction taking place at anode? Chloride ion will migrate towards anode Cl minus. Anode is positively charged, so it will lose its extra electron and become neutral. So chloride ion loses its one electron and become neutral. This is called discharging of ion. Now again we see that chlorine is a diatomic gas, so it will not exist in free state, but it combines with another chlorine atom and Cl2 gas will be released. One more thing, student, here there is loss of electron. So here oxidation is taking place, because we know that loss of electron is oxidation. So at anode oxidation takes place. Now come to anode, cathode. At cathode, cation Na plus migrate towards cathode, and from this negative electrode it receives electron and changes to sodium. Now this is neutral. Again, since the charge is lost, so this is called discharging. And again we see here is the gain of electron, therefore it is reduction. So what do you see here, students? That is, during electrolysis at anode, anion lose electron to become neutral. This is oxidation. And at cathode, cation gain electron to become neutral. This is reduction. Since oxidation and reduction take place simultaneously, therefore electrolysis is a redox reaction. Clear, student? Students, now in this part we are going to explain some terms related to electrolysis. And now the first term is electrode. Electrode. The two conducting rods or plates. Conducting rods that may be made up of metal, graphite or gas carbon. The two conducting rods or plates introduced in the electrolyte through which current enters or leaves it, leaves the electrolyte are called electrodes. Now you see here, that is, we have two electrodes. One is anode, another is cathode. Here you see anode, this one, current enters through the anode and it comes out through the cathode. So this is the completing the circuit. Now as we know, if there are two rods, so one rod is called anode. Now as we see here, that is, it is connected to positive terminal of the cell. Current is entering here. And the third point is that you have studied in the previous example that at anode, anion on migrating to anode lose extra electrons. So oxidation takes place. So in short form we can write here, that is, it is connected to positive terminal or pole of cell. First point. Second, as we know, current passes from positive to negative. So in that case you write that current enters the electrolyte. Current enters the electrolyte through it. Now similarly, we have explained that in previous example chloride ion was losing electron here. So at anode oxidation takes place. So we write here, that is, it is an oxidizing electrode. That is, at anode oxidation takes place. So these are the 3 points related to anode. On the similar basis, you can write here about the cathode, which is the negative terminal of the negative electrode of the cell, electrolytic cell. Now, similarly, you write it is connected to negative pole of cell. Next, as we have studied that current leaves the electrolyte through cathode. So, current leaves the electrolyte through it. Current leaves the electrolyte through it. And lastly, the cation migrate to cathode and by accepting electron become neutral. That is the reduction. So here it is a reducing electrode. So some points should be remembered here. That is, the current enters through anode and current leaves through the cathode. So this is the electrode. Now here we can further write here that cation are discharged at cathode, anions are discharged at anode. Cations, that is at anode, at cathode, metallic ion and the hydrogen, which is exception, will be discharged, whereas at anode non-metals are discharged because non-metals are the electronegative in nature. Now next point, next term related to it is that is the electrolyte. The chemical substance, the chemical compound, generally they are ionic compounds or sometimes polar covalent compound in aqueous solution. The chemical compound which allows current to pass through it in molten or aqueous solution state are called electrolytes. The chemical compounds which allows current to pass through it in molten or aqueous solution state is known as electrolyte. Like these are ionic compounds or polar covalent compound in aqueous solution state. Clear? Now third term is the electrolytic cell. The electrolytic cell, also known as voltmeter. You should remember here, student, this is not voltmeter, this is voltmeter. Electrolytic cell. Now this complete setup is known as voltmeter or electrolytic cell. So a non-conducting vessel usually we take glass. Non-conducting vessel containing two electrodes and electrolyte for the process of electrolysis. A non-conducting vessel containing two electrodes and electrolyte for the process of electrolysis is called electrolytic cell. Now in this case we see that we supply the source of direct current, that is it uses direct current. direct current source from outside. That is, we can say that is, as a chemical change, it changes, it converts electrical energy into chemical energy, or that is electrical energy into chemical energy. Means when electricity is supplied to it, when we add the source of electric current to it, then using that electrical energy, it causes chemical change, hence it converts into chemical energy. Now this is the electrolytic cell. Comparing it with electrolytic cell, now we have one electrochemical cell. Electrochemical cell. Now this is the cell in which when chemical reaction take place, then it acts as a source of electric current. So we write here, that is, it converts chemical energy into electrical energy. That is, when chemical change takes place inside it, in the electrolyte of it, then it acts as a source of electric current. Now example, simple voltaic cell, Daniell cell, etc. So these are the source of electric current, direct current. These are the electrochemical cells. So students, we have studied some terms used in electrolysis, that is the electrolytic terms. Now further we have to study here some points to create difference between certain topics. And what are these? If we have to differentiate between cathode and anode, then we have written 3 points related to each one of them. If they are written separately in column, it will give us a proper difference between the two. Now, one more thing, that is, there are some differences further, that is difference between metallic and that is electrolytic conduction. Now we see here, that is, if we study it in column, then we see here, that is, in this case we see that suppose we write here metallic conductor. Suppose we use copper, and electrolytic conductor, that is, suppose CuSO4 solution, that is chemical compound. Then we can differentiate in it. We see that metallic conductors conduct electricity in solid state. Metals conduct electricity in solid state. Here they conduct electricity in molten or aqueous solution state. We will study later on that electrolyte do not conduct electricity in solid state, and there will be some reason for it. Now, metallic conductor conduct electric current in one stream, that is due to the flow of electron from negative to positive, that is current flows in one stream due to flow of electrons from negative to positive pole, negative to positive pole or negative to positive terminal. Remember, here we have written flow of electron. It is opposite to the flow of current. Current flows in the direction opposite to the flow of electron. That is, current flows from positive to negative, whereas electron flow from negative to positive. So actually the flow is of free electrons. So don't be confused with the flow of conventional current. Now here the flow of current in two streams, that is cations towards flow of current in two streams due to the movement of free ions, that is we see here cations towards cathode and anions towards anode. So the towards the anode. So the flow of particles, charged particle, take place in two directions. Cations migrate towards cathode, anion migrate towards anode. So there is the bidirectional movement of particles, whereas in this part the electrons flow only in one direction. Now, third point. Here during metallic conductor there is no chemical change, that is the flow of current through metal is a physical change. Means when current passes through a metal, then there is no chemical change taking place. That is, there is no movement, that is formation of new substance. Only when current passes, the metallic component gets heated, and when it is cooled, that is when current is stopped, it will be cooled. But there is no change in chemical nature. But here the flow of current through electrolyte is a chemical change. Chemical change means during this process new substances are formed. Like in the example of sodium chloride, electrolysis of molten sodium chloride, we have seen that at cathode sodium metal was formed, discharged, and at anode chlorine was produced. So we have taken sodium chloride, but the product was sodium and chlorine. New chemical substances are formed. So this was the chemical change. So this is the difference between metallic conductor and electrolytic conductor. Now, students, there is again another difference. That is, when chemical substance decomposes, it will change into ion. Now there is two terms to describe their decomposition or separation of ion. That is called ionization and dissociation. Where will you use the term dissociation? And where will you use the term ionization? So we again write here, that is difference between dissociation and ionization. Dissociation and ionization. Now, the dissociation, as the name suggests, means separation. So, the separation of ions of a compound in fused means molten, or aqueous solution state is called electrolytic dissociation. Means the ions are dissociating, that is separating. It means that the ions are already present, but here there is no ions initially present. That is, the formation of ions from a compound which does not consist of ions initially in aqueous solution is called ionization. Now we see that, as already we have studied, that there is a separation of ions, means the ions are already present. So we write here that ionic compounds undergo dissociation in molten or aqueous solution state. Like you see, suppose we have NaCl. Then NaCl already consists of ions. The ion is not has to be formed. Already there is the presence of ions. They are required to be only separated. So when it is melted, that is fused, or aqueous solution, that is when dissolved in water, then the ions become free. This is called dissociation. Here this is a chemical compound, already contains ions, but in solid state ions were strongly held, but when it is melted in liquid state or dissolved in water, ions become freely mobile. So this is called dissociation. But in this part you see that polar covalent compounds undergo ionization in aqueous solution. Now here is the covalent compound. So this consists of molecules, but since there is the polar covalent compound, therefore, like you see, suppose we have HCl, delta plus, delta minus. This is polar covalent compound. In liquid state, it consists of molecules. It does not have ion. But when dissolved in water, then it gives us H plus and Cl minus. So this is called ionization. Now, students, we have discussed several terms related to electrolysis. Now, there are some more terms and then other topics related to electrolysis, which we will study it in next video or next class. Thank you.